Yes, class. Am I audible to all of you? Amna, Austin, Deborah, Fadil, Uma, Shahid, Chavez. Sidra has already responded. Okay. So yes, I hope you have written the question. We stopped at the formula for spherical lenses, right? So see, let me draw the figure first. See, this question says a sunshine recorder globe of 30 centimeters diameter. Fine. This 30 centimeter in diameter, this says that is made of glass of refractive index 1.5. A ray enters the globe parallel to the axis. Find the position from the center of the sphere where the ray crosses the axis. See, this, suppose the light ray enters, the sunshine ray, this is entering. This point is A point. It will get refracted. Let's say this point is B. Again, this had to go over here. This had to reach this point. Suppose, let's say, but because of the differences, here the image had to form if there were no any refracting surfaces. Now, because of the refracting surfaces, there is a change in the medium. See, we studied it like two halves only, no? One portion, remember? So here this will bend and here you will get the final actual. Correct? Center of curvature will also be there. Right, center of curvature for this entire sphere, and this will be how much? This separation, this will be 15 centimeters because total was 30 centimeters. This is one pole P1, this is second pole P2. Though you can get one question also where you just have one part of it, where you can get another part of it. Fine. Now what all details are mentioned? Something refractive index is given and 30 centimeter diameter is given. Okay, so other medium is here. So one more refractive index you have. See what all information we have with us. Refractive index of air, this is 1. Refractive index of glass, this is 1.5. This you already have. Fine. This you already have with you. 1.5 is for glass and 1 is for outside air. Now what do we have to do? This is air, this is glass. No, not every time it would be mentioned. See, air, refractive index of air, glass, water. These three you should remember by yourself. Fine. So, radius of curvature that we'll be taking, radius of curvature will be 15 centimeters. Why? Because see, 30 centimeters divided by 2, entire diameter that was given. This is the radius of curvature. Correct? Radius of curvature. Now, object distance you have to consider. What is the object distance that you will be putting? See, sunshine is given. Object, there is no specific object. If sunshine is given, where is sun located? If I am saying it is coming from the sun. Infinity, very good. Correct, Chavez. Object distance will be infinity. Because this is coming from sun. So you will directly take it as U. Now calculate the first, this image where this is formed. Let us calculate this image first. So we'll have an idea, or let us just calculate. Let us just calculate this also. Let us get the value. How much extra we are getting it. How much is the image function. So we have studied this formula. Mu2 divided by V minus mu1 divided by U is equal to mu2 minus mu1 divided by radius of curvature R. So let's substitute all the values. This is 1.5 by V minus 1 by U was infinity. Though you have to put minus sign also, but there is no significance of it. It would be negative. This is 1.5 minus 1 by the radius of curvature is 50. So this we have. So from here, image will be what? This becomes 0. This gets cancelled. This becomes 0.5, 0, so 3, so 45. Correct? Just cross check someone. This should be 45 centimeters. Right? Agreed or not? This is 45 centimeters. Why object distance is infinity? See, it is not telling you that object is located at a certain position. What it is saying, a sunshine recorder globe of 30 centimeter diameter is made of glass of refractive index this. Ray enters the globe parallel to the axis. Don't go by the figure. Actually, I have not drawn it properly. This is actually parallel. This is parallel. It means object distance is infinity. We have studied the rules and laws of reflection. There we studied this fact, right? There we have studied this fact. So you should know whenever it's and it is also clearly telling you sunshine recorder. Even that parallel axis information was sufficient, but now it is mentioning you about it. All right. Now this gives you the image distance. So you had to what you had to calculate. Find the position from the center of the sphere where the ray crosses the axis. So where the ray crosses the axis, that would be the entire separation. All right. So from the center, if it is saying, so from the center of curvature only we have the distance. So answer should be 45. Yeah, I'll show the question. Wait. Yes, class. See, this question says here you have to find the power also. Power and focal length. I hope you have tried this, written at least. Mu is given as 1.5, 1 at 10 centimeter. Let me read the question. What curvature must be given to the bounding surface of refractive index 1.5 for virtual image of an object in the medium of mu is equal to 1 at 10 centimeter to be formed at a distance of 40 centimeter. Also calculate power of the surface and two principal focal lengths of the surface. Now, see, what is the object distance given? Object distance is given as -10. Whatever data is given to in ray optics, write down that first, because you have to substitute it in the formula ultimately. Correct. So, and it is saying to be formed at a distance of. It means it is saying image is to be found at a distance of. It is to be found at a distance, right? It is to be formed at that. So this means this is image distance also, -40 centimeter. Correct. Then it is saying you have mu1 as 1, you have mu2 as 1.5. Everything is there. R is missing. We can calculate the radius of curvature using the spherical formula. Mu2 minus mu1 by R is equal to mu2 by V minus mu1 by U. So when you substitute in everything, this becomes 1.5 minus 1 by R is equal to 1.5 by -40 minus mu1 is 1 by 10. This is -10. So if it is -10, minus will become plus. This will become plus then because of this -10. So what we'll have? This is 40. This will be 40. This will be 2.5. 0 will come here. 1 over 16. Here it will be 0.5. That is 1 by 2. So 2R is equal to 16. Or you can say simply 0.5 into 16. That is 8 centimeter. This is the radius of curvature. Now see, you have to find out the power it is saying. Let me tell you the formula. The power we haven't discussed. No. Power you will be discussing it separately also. You have a formula for power. Mu2 minus mu1 divided by R. This will give you the power in diopters. We will be studying lens maker formula you have. There we will be studying power also. So 1.5 minus 1 divided by 8, that is 0.5 divided by 8. Now, in power, no, you have to convert this into centimeters. So this into meters, sorry. This is given in centimeters, no, for calculation of the questions of power. You have to convert it into meters. Because finally this becomes 6.25. Diopters is the unit, SI unit of power, which is calculated with meters in the denominator. We'll be studying power. That's why I'm not going into the details of this. There is one more shortcut formula to find out the focal length directly. You can write it minus mu1 by R, mu2 minus mu1. When you have two foci, no, such in case like this. Here you can substitute for F2 also you can calculate. See, for F2 also you can substitute minus mu2. Now for this will be plus mu2 by R, mu2 minus mu1. You can substitute all the values. F1 also you will get, F2 also you will get. Let me put in only and check. Minus mu1. So this is 8. So this becomes minus 8 by 1.5 minus 1, that is 0.5, which is minus 16 centimeters. Then this is 1.5 into 8 divided by 0.5. 324 centimeter. Like this. Write it down. Question you all have written, write down the solution. And this power concept, no, don't worry about it. Just remember the formula right now. We
Ma'am,
have
can you
lens
show
maker.
the question also?
Yes, I'll show you the question. We have lens maker formula, so there we'll study power also.
Ma'am, before this class, what did we do? Can you just say me?
Yes, Sophia, you're asking something?
Yes, ma'am. Before this class, what did we do?
Before this class, yeah, in the last class.
Yes, ma'am.
Spherical refracting surfaces, this formula, this we derived.
Yes, ma'am. Thank you. Ma'am, I have a doubt. Why we did not write 1 by -10?
Fia, I told you, no, we had written 1 by -10. This minus and this minus, they made it plus. Ultimately, we'll add it. No, that's why I wrote plus ultimately. Because
Okay,
in the end, we'll have to add it. Okay.
yes, ma'am. Actually, I joined a little bit later because of that.
Acha, in the middle of question, you have joined. Okay, okay.
Yes, ma'am.
And Fia, what about the recording? Just check the recording also of the
Yeah,
last.
recording I have finished, ma'am, of spherical refracting
Okay.
surfaces.
P is power, power. Power we'll do. Power is 1 by F only. This will give you 1 by F itself. This will itself give you 1 by F. Put 1 by F, you will get this formula. From that only, Shayad, I have calculated the formula for F1 and F2. Power is 1 by F only. But you have other formula for focus. For focus, you have so many formulas. So that's why when you write 1 by F, you get so many formula for power as well. Okay, from this only, I have got this.
Ma'am, actually, this week there was a physics test, right?
Yes, Fia?
Ma'am, this week there was physics test, right?
This week?
This week they held a physics test, ma'am. From that, can you just, when we get time, can you just clear me the fourth, third question?
Numerical one?
Yes, ma'am.
Okay, Fia. First, let me check your papers and also I'll discuss accordingly. I'll discuss the entire paper only then. 3 questions were of derivation. है ना? Magnification
Yeah. Only two
mirror
was
formula. 2
numerical.
numericals were there. Okay. Okay. Both the numericals I'll
Thank
discuss
you.
then. But let me check your papers first. I haven't even received them. Let me check your papers, and some of you do not know how to write the papers, and some of you are not even attending the papers. Those who are attempting and scoring whatever, that is fine, but some of you I haven't seen one single paper. At least attempt your weekly tests, and they also, I think, alternate Fridays these tests occur. This Friday it occurred, previous Friday it wasn't there, so you have 2 weeks time. Also syllabus was also very less, only reflection. Right now I don't know how many of you have attempted or not. All of you have attempted. Those who have attempted the test, Friday's test, just write yes in the chat column. And yes, one question. uh, uh there was a question regarding magnetics. Define 1 ampere in terms of magnetics. All of you have just written force is equal to 2 into 10 to the power. You have to mention that if force is coming to something, you have to write how have you obtained that. Calculation part nobody has shown. I specifically told you, you will show and put that this is equal to 1, distance is equal to 1, mu naught into 4 pi we are putting, that's why we are getting this value. 2 into 10 to the power minus 7, you will show how you are getting, because 4 pi is getting divided by 2 pi. Nobody has shown that. Okay, Shavez didn't. Shahid, you also didn't? Okay. Austin, good. Austin has been attempting all the tests well also. Sidra has attempted. Fia. Humam has also attempted. Okay. Okay, Deborah has also good. Let's discuss this. An object is at a distance of 20 centimeters from a spherical refracting surface of radius of curvature 10 centimeters. Calculate image distance of refractive index of glass 1.5. See, this is basically like this. You are having a surface. This portion here, let's say this is 1, this is 2. This is 1.5 glass. Here we'll take 1 only. Light ray, this is coming. This is the direction. So this is the object which is kept at a distance of 20 centimeter from the pole. This is kept at a distance of 20 centimeter. Center of curvature must be somewhere here, which is 10 centimeter. So first refractive index is 1, second refractive index is 1.5. Object distance is minus 20 centimeter. Radius of curvature is plus 10 centimeters, and image distance you have to find out. So we'll put in the formula n1 by here, if n1 is there, minus u plus n2 by v is equal to n2 minus n1 by r, sorry. This will be r. So substitute in the values. This will be 1 by minus 20. Already this minus sign is there. So 1 more minus. Understood? 1 minus because of the formula, and u is already minus 20. So 1 minus 20 because of this. All right. Then plus, this is 1.5 by v is missing. 1.5 minus 1 divided by 10. So 1 by plus 20 plus 1.5 by V is equal to 0.5 by 10. So 1.5 by V is equal to 0.5 by 10 minus 1 by 20. This will be 20. Here you will multiply it by 2 minus 1. So this will become 1.5. This is 1. 1 minus 1 is 0. This is 0. So image distance, this is coming. V will be 1 by 0. What is 1 by 0? Yes, class. What should be the final answer? Yes. Till here I have solved. Correct. Shahid has answered correctly. Shah is correct. 1 by 0 is infinite. Infinity. Infinity. Image will be formed at infinity. This was the solution. Yes, infinity. Correct. Write it down. This was the last question from this spherical refracting. Now we'll start with lens maker formula. Before that, we'll properly start with the lenses. Lens we didn't discuss, no? Lens we'll start. First, we'll do the lens. Yes, class. Now starting with lens. So before we start with lens, make a formula. Let us talk about lens. See, lens, you have two spherical refracting surfaces. Like one refracting surface, if I take. All right, I have this one refracting surface with me. I've just, from the entire hollow sphere, I've just taken this part. And one more part I have taken. Now, when I'll join these two, it will look like this. That gives me a concave mirror, a convex lens. And if I join it from the opposite side, means from this side, if I will join these two, so it will be like this. Clear, class? This is what is basically its combination of two spherical refracting surfaces. It can be concave, it can be convex. Like this, you have the convex lens. Here, light rays will come and they will converge at a point where you will see. And see, if I take, this is biconvex. See, you can see two lenses are present, so biconvex. On this side, this is plane. This side is plane. The way you have plane mirror, this side is plane mirror. This side is convex. So this type of lens is known as plano-convex lens. This is already convex, but this side, this is concave. Instead of pasting this opposite in this manner, we have pasted it like this. So this is concavo-convex lens. Biconvex is also known as double convex. Similarly, this is concave. The way we have the importance of concave mirrors, here you will be having importance of convex lens. Mirror you will be seeing very less. So this is biconcave lens. All right, this is double convex. Here the light rays will diverge. The convex lens have the tendency, they have the property to converge the light rays. Whereas these concave lens have the tendency to diverge it. So converge in convex, diverge in concave. So this is biconcave lens. If you take again plano-concave lens, one side plane. Now see, if I'll take convex again, so what it will become? It will become convexo-concave. Concavo-convex or convexo-concave. Both are the same thing only. Write this down, then we'll see what are the markings of it. Like you had no center of curvature, pole, focus. Similarly, we'll see what all parameters are there in the lens because you don't have the pole here located. I'll tell you, write it down first. Now see, let us look at all the parameters which are present, what all things are there. See, when we are talking about the pole of the sphere, pole is again located here only, at the interface or at the intersecting surface of the axis and the spherical. Now see, this center of the lens, this is known as the optical center. The center of the lens, this is known as the optical center. And this is how a light ray will come and it will go. Now look what happens here. If you look at this circled and this circled portion, do you see there are two surfaces? Air, glass. So refraction will occur. Again, glass, air. So again, refraction occurs. So in general, it occurs twice. But whenever you will be using it, you will be seeing it that we draw it separately. We don't draw it separately. We write it as one only. Like light rays are coming and one either conversion or diversion. Why? Reason is that this separation between P1 and P2 is very, very small. Understood? This separation between P2 and P1, this is very small. If this separation is very less, then this deviation is also not very much. Otherwise, how should it had to be drawn? Like this, then refraction. Then here, then again, some refraction like this. But we don't draw it in that manner. Reason is that aperture is so small. Aperture is so small. Then focus. Now see, in lens, we'll be having two foci. The way we have two principal of it, we have two poles of it for one single principal axis, you will be having two focus of it. Reason behind is that because you have two spheres, the lens have been made by combining two lenses, right? Two spheres. So there are two foci also. One for this portion of the lens, one for this portion of the lens. Now remember one thing. In your convex mirror, when we are talking about convex mirror, this is the second principal focus. This is the first principal focus. So when will the light rays converge and when will the image be formed at the second principal focus? When the light rays are coming from the first principal focus side, correct? And when will the rays at first principal focus be made? When the object is kept at second principal. Correct? Because this is not the case of mirrors where you have silvered one side. So if you are bringing the object behind the mirror, you will not get any image. No, here they are transparent. Both the sides are transparent. All right. So they will be converging at one point. So second principal axis, first principal axis. This is for convex lens. All right. And most of the images will be formed at the second principal focus. Maximum images will be formed at second principal focus. When we're talking about concave, this is F1, this is F2 again. So when light rays will come from your same thing, just where there were convergence occurring and then here is divergence occurring. Our lens maker formula I'll tell you later. First write down this. Fine class, tomorrow I'll start with the derivation of lens maker formula. Basically, you have the relationship between the radii of curvature, both of them, refractive indices of both the surfaces, and focal length. So from this, you will be able to calculate power also. I'll discuss it tomorrow only. So lens maker formula will be completed. Actually, by this week, I told we would have completed ray optics, but last weekend you had the Diwali break. So optical instruments, okay, next Saturday we'll be requiring. Anyways, if we get sufficient time, we'll then have extra class also for this. But I think we'll be able to complete this. Let's see tomorrow how much we are able to complete. Lens maker, at least we should be able to complete. We'll be able to complete lens maker entirely. I hope we are able to start with optical instruments. This optical instruments topic, this can be completed in one class. Telescope and prism can be completed in one class. All right, you all can start leaving. Tomorrow we'll continue.